Hello and welcome to today's tutorial, Project Organization. In this video, you'll learn how to best organize your projects as to maximize efficiency, yours as well as that of your automations. The subject of organizing your project might seem tedious, but it is a vital part in successful automation projects. What we'll look at today are the lessons we learned during our experience implementing large projects for some of the most influential companies in the world. We've distilled these lessons into a series of best practices that will make your automation projects more reliable, efficient, maintainable, and extensible. These are welcomed qualities in most cases, but in larger enterprise process automations, they become key requirements. Reliability is a characteristic we want in all automations, and we discussed it in depth in the previous video, Exception Handling. It deals with teaching your automation to recognize and recover gracefully from various errors that might occur, internal or external, because as we all know, they will. Efficiency is about cutting down development time through various methods, but also about making sure that the automation runs smoothly in production conditions. And having a workflow that's easy to maintain is essential in business environments, where collaboration and handovers are the normal way of operating. And so is extensibility, because there will always be more use cases that can be incorporated into existing automations. These are just the main benefits of applying best practices to your automation, but you'll probably encounter other advantages too. So let's see, what are these wise lessons passed down from one generation to the next? First of all, when you start a project, make sure you take a moment to choose the appropriate layout for each workflow and its sub-workflows. You can do most tasks in UiPath in either a sequence or a flowchart, but in practice, some things are better suited for flowcharts and others for sequences. For example, the main workflow works better as a flowchart for a few reasons. It's easier to get an overview of the whole project, and it's also easier to test individual parts of the workflow by connecting them directly to the start node. Sometimes it's a good idea to use a state machine for your main workflow. It works especially well if you have multiple strict conditions for when your workflow can move from one state to another. We'll take a look at that in a separate video. And in general, higher level decisions or business-led choices work better in a flowchart. UI interactions are performed one after the other without much variation, so they're better suited for a sequence. And try to avoid nested if statements, because they can get a bit unwieldy and hard to follow. If you need more complex logic, the visual nature of flowcharts makes them much easier to comprehend, so much better suited for this purpose. To understand why breaking an automation into smaller components is important, you must remember that much of what we do as automation developers consists of managing complexity. We implement very complex applications and algorithms by breaking them up into smaller, manageable tasks, and that brings a lot of advantages. It's easier to develop and test the functionality of independent pieces. You can make sure each piece works on its own, and then you can tie them all together. It also cuts developing time by reusing the same functionality in different parts of the project. It's easier to collaborate with multiple people on the same project in a local or remote environment. Besides workflows and sequences, an even better way of isolating pieces of automation is using the invoke command, and later we'll take a closer look at how to use it. Exception handling should be used to capture and handle errors, or at least log them for later analysis. You can put problematic sequences, like, let's say, some sensitive UI interactions, inside a try-catch block, and this ensures that your automation will not crash and stop completely for every minor error. Try-catch should also be used when invoking external workflow files. It helps in debugging and in the process of recovery. Automatic recovery sequences placed inside catch blocks can make your automation very reliable. They make the difference between an automation that works most of the time and one that is rock solid and almost never fails. So whenever possible, implement a sequence which will reset the application or process into a usable state in the event of an exception. We talked about keeping your projects clear and readable in the previous episode too. It's essential for efficient debugging and also in team projects where other people need to use your workflows. As you probably know, giving descriptive names to all components and leaving clarifying notes and comments is imperative. And don't forget to log the execution progress too. It keeps you in the loop with what's going on, and it helps pinpoint errors faster. Another useful trick when deploying large projects is to keep settings of your workflow in a separate file. We recommend a JSON file, but you can use a CSV or Excel or text file if you prefer. It's an easy method that simplifies changing the parameters of your robot, even without starting UiPath. This one is indispensable. If you don't clean up by closing unused applications and windows, after a few iterations there will be countless instances that will slow down and eventually crash the machine. Right, so these are the 5 commandments of UiPath automation, if you will. Feel free to refer back to them if you need to refresh your memory when starting a new project. But anyway, enough theory for now, let's move on to more practical aspects. We'll come back to higher level organizational issues in a minute, but before that I want to quickly show you a few more details about the invoke command that we mentioned earlier and in the previous video too. It's one of the main tools for breaking up a project into smaller components, and it's pretty powerful at that. It is available as an activity that you can drag and drop like any other one, but most of the time you will use it differently. You can simply right-click any sequence or flowchart or any other container or activity and choose Extract as Workflow. All you have to do is choose an appropriate name for the extracted workflow. UiPath will automatically replace the selection with an invoke activity. Essentially, you just made these workflows into functions that can be reused in other parts of the project or maintained and improved by other people because they're simple files. And more importantly, each piece can be independently tested. Right, so that's pretty straightforward. Right-click, extract workflow. But the real power of this technique comes from the data that can be passed back and forward as parameters or arguments between the main workflow and its invoked descendants. For example, we have this workflow that enters data into a My CRM app with data coming from these 4 variables declared globally in the flowchart, not the current sequence, and there's also a local timeout variable. When we extract the workflow, all 4 global variables become arguments, and the locally declared timeout variable will remain unchanged. And in the original parent workflow, we have the invoke activity. There are no arguments by default, but clicking import will bring in all those declared. Here, all you have to do is decide what data to populate these arguments with, or in our case, what data to enter into the CRM app. You can obviously use raw values, and that is useful on its own, but most often you'll use variables. Basically, you'll run the process with different data. You get the idea. In the direction column, you can choose to pass data into the child workflow, like we're doing here, or get data out of it if the called workflow generates some data that you need accessible from the parent, or both, in which case the data is passed both ways. For this instance, we need to pass data into the process, so we'll leave them all set to in. And let's test it. Great, it entered the dummy data that we passed as arguments, but sometimes you need to get data from a child process into the current workflow, like this get user sequence that uses the privacy website fakenamegenerator.com to create fictitious user data. These get actions extract data from the website and store them in these globally declared variables: get name, get address, and get email. And here's the result. The difference from the other workflow is that now, after we extract this workflow, the imported arguments should be set to out because we want to get data out of the called workflow. UiPath automatically set them to in and out, which also works fine. We don't need this new line variable as an argument, so we'll delete it. Now we can go in the parent workflow and import the getUserData arguments. For outgoing variables, the value is where to store the produced data. We'll put each one in its local corresponding variable left behind after the extract workflow. So now, in the parent workflow, we have these two invoke blocks, one that gets data from a website and one that enters data into another app. They're independent from each other and they can be used and reused however and wherever you need. To use them together, connect the two. Then go to the enter user data invoke block and in its arguments window pass it the local variables, the ones that are used to store the extracted data from the first invoke, get user data. Now let's see how it works. The name and address could use a bit of processing, like splitting them up, but we'll see about that later. As it happens, these two invoke commands are a great introduction for the next section, project organization. We'll build a full project, starting from these two sub-workflows, to show you a real-world example of project organization. So, let's say we want to make a robot that generates 10 users and enters them in the My CRM. Similar to the workflow we just made, but for multiple users, and we need it to keep a log of all the operations and their status, as failed or succeeded, because it will run unattended. And because it will run in an enterprise environment, it should be reliable, efficient, maintainable, and extensible. So let's plan this out a bit. We need to extract user data from a source and load that data into a destination app, so we can break the workflow in two. To get the users, we need to open the website, generate a number of users using the workflow we created earlier, then close the browser. And for reliability, we'll put everything inside a try-catch block. It's pretty easy. The other half of the automation starts off in a similar way. We open the app, insert X users, and close. Because we need individual status reports for each user, the try-catch block will be inside the insert X users loop. And here too, we can use the other workflow that we created earlier, enter user. And in the catch section, we'll log the success or failure of the operation in a separate Excel file and then initiate recovery methods. As you can see, this sketch already gives us a good idea of what we have to do. So let's give it a try. We'll go over details faster than usual because we want to give you a high-level overview of the process without getting lost in the technicalities. And you'll be familiar with most low-level aspects of what we'll do anyway. We'll start with an empty flowchart named 0 main and creating the two sub-workflows, get users and insert users. We'll actually make them separate workflows so they're easier to test, and we'll name them starting with numbers. This ensures they stay in the correct order in the project view and maximizes readability. This setup will give us a structure to build upon. For get users, we'll start with the try-catch block that will hold all the actions. For starters, an open browser. Now that we have that, let's add the most important part, the loop that will generate a number of users. The loop is just a simple do while with a counter. The important part is this. We'll go to the workflow we made earlier and bring in the invoke action that generates a single user. The arguments were copied along, but the local variables don't exist here. We'll just create new ones with the largest scope. Next, we need to somehow save the results of the get user data sub-workflow. Now we'll do that with a simple data table, one row per user. We'll create it before we open the browser and write it to disk after all the browser data extraction ends. In the build data table activity, we need to set up all the columns for the user data, basically what we extract from the website, and add an extra one for the transaction status. And inside the loop, we'll populate the data table by adding each name we generate as a new row in the data table. We'll simply use the get user data's results to create each row. Finally, we'll write the data table to disk. And also print it out for verification. Now that should be all. Let's see how it works. Here it is generating each user. And these are the results. The 3 individual users printed from the invoked getUserData workflow, a warning that we can ignore, and the saved data table containing the 3 users. Right, so we're done with user extraction. Next, let's copy all these users from the Excel file where they're saved to our custom CRM app. This time, in the Insert Users workflow, we'll start by loading and setting up the data. After reading the file we saved earlier, there's a tricky part. We said that in the Excel file we'll also keep the status of the copy operation as successful or failed, because we want to avoid any conflicts inside the CRM app. We'll filter just the users that weren't entered at all, aka those with an empty status field. We'll use an assign activity. The filtered data table will be saved in a rows variable, which is of type array of rows. And the value we'll assign to it is our data table, select, all the rows with an empty status, or null. As easy as that. Select is a very useful tool, especially if you work with spreadsheet data. You can find out more about its syntax by doing a web search for data table select. Okay, we're done here. Up one level, we'll just add an open application for our CRM app. So, the processing. We want to make a flowchart loop to add users one by one, hopefully using the enter user workflow we created earlier. Basically, we'll ask, are there users to be added? And if so, enter the loop and try to process the first one. If it succeeds, it will go ahead and process the next one and so on until all the rows are processed. When there are no more users to add, close the app and the workflow is done. Let's take them one by one. To know if there are any users to add, we'll need a counter, and we'll set one up and initialize it with 0. So for the condition, we'll have counter is smaller than total number of rows. If the counter is smaller than the number of rows, it means we haven't reached the end of the user list and we can start adding the next user. The add user block is where the meat of this action is. First of all, it's not a sequence, but a try-catch block. This way, if an error occurs, we'll be able to catch it and write the appropriate status in the Excel file and then carry on with the next user. We'll start with a log message that will give us real-time execution tracking of the process. This way, when an error occurs, we'll know what was happening at the moment so we can locate and solve the problem quicker. Next, we need the most important part, the one that inserts users into the CRM app. We'll bring in the invoke activity that calls the workflow we built earlier. Copy from here to here, and we just need to pass it the user data to enter in the CRM app. Let's see. In the load users sequence, we load the data from an Excel file and then select the rows which have an empty status and store all of them in the rows variable, which is an array of rows, with the current user being held in the counter variable we set up. So, back in our invoke command, the arguments look like this. We'll start with the address. The current row is rows at position counter. This is the whole row, but we just need the address. That is the column name we set up in the build data table action, and we'll convert it to string. The others are very similar. Rows at position counter and the appropriate column name to string. There's a small problem though. The CRM app requires a first and last name, but the generated users have only one full name field. We need to split it in two, using the space character. The result of the split operation is an array of strings. So for the first name, we'll get the first element, and for the last name, the second. 0 and 1 being the first and second elements in zero-based numbering. This method isn't 100% accurate for all types of names, but it will work for our example. As you might have guessed, finding this correct formula sometimes takes a bit of trial and error, and that is where breaking up the process, as we did, has huge advantages, because otherwise we'd have to run the whole process every time we want to test it, including the part that generates users, and we certainly don't want that. Running only this workflow is much quicker. Okay, that should be it. Next, we'll set up a variable, we'll call it haveError, to keep track of how the operation completed, successfully or not. Since the process got up to here, it means it was successful, so we'll set it to false. Then, for debugging and process tracking, we'll log the successful operation. but more importantly, we want to write the status of the operation in the Excel file. So we'll add an Excel application scope and have it open the same users file that we saved in the extraction workflow. Then add a write cell action to write the OK status. The actual location of the cell is a bit crafty. Here's how it works. If we take a look at the Excel file, we want to write in the D cell. So our location should be D, plus the row of the current user, the one we just entered into the My CRM app. The current index of the user is stored in counter, but it's based on the array of rows we created using the selected command. So we will search for the current user in the data table containing all users using the index of command. And when one is found, it will return the index of that row or user for us. But to be exact, we also have to add two. One because of the zero-based numbering, and one for the row of headers we have in the Excel file. And that is how we find the correct location in the Excel file. Again, a bit of trial and error was involved. As it is, this workflow is already functional, so you can try it out, but we'll go on to set up the catch section, aka what happens if there is an error. As usual, we'll start logging the failure of the transaction with a complete message and source of the error. Then we'll set the error flag to true, and this is important later because we'll use this flag to recover from errors. Now if there has been an error, we need to log that error in the Excel file too. So we'll just copy the Excel section from the try block and paste it here, changing only the message from OK to fail. The location remains the same. Back in the root level of the workflow, we have one more activity to set up, the success or error decision box. We already have the condition. It's the error flag we created in the add user sequence. Since it's a Boolean value, that's all there is to it. To simulate a crash, we'll manually close the app while the workflow is running, so the recovery procedure will be simply reopening the CRM app. That's accomplished by connecting the true port of the decision with the open application action. Depending on the type of error you're recovering from, you can have more complex recovery methods, but in our case, this will be enough. And finally, time to see how this workflow, which is the second half of the project, actually runs. We'll have the user's Excel file open so we can see the real-time feedback of the operations. Here it is entering the first user from the Excel file and writing the OK status, and the second one. Also successful. For the third one, we'll close the app to mimic a crash. And here's its fail status. And then the app recovers and continues to process the next user. If we kill it again, same thing. We're going to let it finish. We don't want to make it angry. We're almost done with this workflow. Let's just clean it up a bit to make it more readable and flexible. First, in the project folder, we can remove the parent invoke workflow since we don't need it anymore. And we'll rename this getUserData file to make it obvious that it's called by its parent getUsers. Much better. And to make it more flexible, we'll create a new file to keep all the settings in it. You can use Excel files or CSV, but we'll go with the JSON format since it's the easiest to edit and to use inside UiPath. So let's make a new file in the project folder. We'll name it config and use the basic JSON syntax. We'll create two parameters, the file path to the user's Excel file because it will certainly change for each deployment, and the number of users to extract at a time. And save. To use these variables in the workflows, we need two actions. We'll put them in the load users sequence since it's at the beginning of the process. The first one is read text file. That will read our config file. The second action, deserialize JSON, is an interesting one. It takes the information from the text file and outputs an object containing all our variables from the config file, accessible like so. The name of the JSON object, in our case, global parameters, and the name of the variable we need, users file path. And that is all. Then we'll copy these two actions and paste them in the other workflow, getUsers, somewhere close to the start, and create the missing variables. Here we have the number of users variable that controls the batch size. We'll just assign it the value from the config file in much the same way, except now we'll convert it to integer instead of string. And in the write Excel action, we'll give it the same global parameter, users file path. And now you can edit the config file to change the full path to the Excel file or the number of users it copies at a time, and the workflow will adapt accordingly. So that's all for today's video. It was longer and it involved more theory than usual because it provides important lessons that will help you develop efficient and reliable automations in any environment. Until next time, goodbye.